Yo, what is up, guys? Welcome to another episode of CCT. Today we're going to do another random easy question, and let's jump right into it. Let's go with, this one was catching my eye with a 20% accuracy on an easy level question. I mean, come on. That that shouldn't be an easy question. I feel like there should be some upvoting and downvoting system here on LeetCode to decipher if it's an easy question. Wow, okay. So, given an array with n integers, your task is to check if it could become a non-decreasing by modifying at most one element. Huh. So, okay. We define non-decreasing as it's greater than or equal to successive numbers. So this one, if you change the 4 to a 1, then it is increasing. If you change, let's see, this one, you can't do anything to it. If you change the 4 to be lower, you can't do it. If you change the 2 to be higher, you can't do it. And if you change the 1 to be higher, you can't do it. Okay. Let's go to the board here. Let's get a new file going. Okay, and the color of the day is going to be, how does yellow look here? That's not yellow. Jesus. Okay, what about a lime here? Let's go lime. That's not lime. Yeah, it's like tennis ball color. Ooh, that is that's electric. Ooh, I like it. I like it though. Okay, so what were we doing? Okay. Right. So if we have ints, like 5, 8, 3, 9, or yeah, I can't help but think the best way to do it is to like go through this. Okay, so you have an element and you check on either sides, but if it's the first one, you just check on the right side. If it's greater than this number, great. This number is not the 5 is not what you should modify, which is correct. And then what you do is you move on to the 8 number, and then you check on both sides to make sure this is less than it and this is greater than it. And if like that we get an error here, then we know, well, we actually have two sides. We have to check if this one and, well, actually, maybe we could only check the one above it. So maybe we won't need to check. Like when we did 5, maybe we could just make sure to check that one's greater. And if it is, great, we move on here. And then we make sure the one to the right of it's greater. We already know it's greater than the one on the left, or else we would have done something. So then we get to here, and it's not greater. Then the 3 is not greater than the 8. So 8 is not less than 3. So now we have 2 options. Yes. So 2 options here. Either option, I'll do right like this. So option 1, decrease 8, and option 2, increase 3. Okay, so perhaps what we should be looking at here is, okay, so now we have some cases. So we should see for the decreasing case, so for case 1, is 5 less than 3. So we make the 8 go down as far as it can go. The lowest it could go is 5. Or actually, this could be less than or equal to 3. And this is not true. So that means that's a not possible here. Not possible. And then for option 2, we can see if 8 is less than or equal to 9. And if that's possible, then and that is possible, so then we can return true. So yeah, this is basically the setup. And one thing, I don't think we need to go past this number. So after we do this and check to make sure this is bigger, and this is bigger, we have like, okay, hold on. We have like a Boolean that says already changed one of the numbers, right? Like we already changed one of them. So then we make sure the rest is increasing at that point. But I don't think we need to check this last, oh no, we do. We do need to check this last number. Okay. Yes. Okay. Let's get to writing some of this stuff. Okay. So for int I equals 0, I is less than nums.size, I plus plus, and then let's say I want a Boolean that says changed a number. Okay, so that's going to be set to false originally. So let's see. Okay. If, here's what we're going to do. If nums at I is greater than nums at I plus 1, I'm probably going to at least have to do that, then we go into here. So this could be fine. So then we get into our 2 options. So, we should, yeah, okay. So if, first of all, if I equals 0 here, this number can be as small as we want. So we're going to do 2 things here. We're going to do changed is true. Okay, that's actually all we're going to do. And like that would be signifying that we changed the first number. Okay. So we changed the first number. Yeah, so we can't make any more changes anymore. First of all, actually, something I want to put here is if you already changed, then we got to return false here, because we needed to change somewhere else. Okay. So then, else if nums at I minus 1, which would be this case, is less than or equal to nums at I plus 1, this could be signifying changing the ith value to what I minus 1 is. Then we could do changed is true. Yeah, I'm starting to think, I don't like, when I only have one line, I like to just put it right here. Yeah, just like that. Okay. So, okay, and then else if nums at I is less than or equal to, nums at I is less than or equal to nums at I plus 2. So that would be that one, so then we could change that one basically. Yeah. Yeah, so then we could also have change. I'm just thinking if like we actually need to modify the array for this one, like if we actually need to put an 8 in here because that's what it would signify. But we've already established by the time we get in this part of the function that this number is bigger than this number. So when we go to the next iteration, this is automatically going to be smaller than it. So we don't really need to. Well, yeah, we don't, because even if we had another conflict like here, 7 or something, if we get another conflict and we're already changed, we're done. We're done here. So I think that's all we need to do. We're not gonna like be even looking at this number. Okay, so else if neither of those options are possible, so like if this was a 6 or something, so now none of them are possible, we can just else return false at this point. And then if we get through the whole loop without doing anything, then we're going to return true. Okay, some things that worry me. Here we are doing this. We're checking 2 ahead. Which kind of brings me to another point here that I was thinking about. What if we had something like this? Like this. Is there any point? I think we could stop here. I don't think we need to check here per se. I'm sorry. I think we need to go here and then compare these two relationships. I don't think we need to get to here and compare these two's relationship. I think what we can do is we could actually end too early, like -2 early, and then check here if nums at nums dot size -2 is let's say it is greater than nums at nums dot size -1. Okay, so then that's like this case. The only way this is okay is if that was the only change. So if already changed, return false here. Oh my god. And then if it's smaller than this number, obviously that's fine, and then we don't even have to deal with this. And if it is greater than the number and we didn't do changes before, then that's also fine. However, if 9 is greater than 3 and we made changes previously in the array, that is not fine. Let's return false there. Okay, so we're going to stop 2 before, and let's go through this one more time. So if the current one is greater than the next one, we first check if we've changed before, and if we have, we're going to return false. Also, we're going to check if you are 0, then we can just change. Well, would it make a difference if we changed? No. Okay, so obviously it's going to be better to make this one smaller. This is always, so like that's our change. We just make this one smaller, and if 8 needed to be, let's say it was like 5 here. Let's do this. 5, 8, 5. Oh, wait, this would work actually. So if we're at 0, if we're at 0, we can either decrease 5 Or we could, oh wait, this isn't a problem. This would not cause a problem. What would cause a problem is if we had it like 4, 5. And then here, we could actually solve it by increasing 4. Okay, so that is the problem there. So we could solve it. So we want to say change is true. Oh, wait. Okay. So the change is true. That's fine. And then this would not cause another bad change. So that is fine also. Because if it's going less than it, the only way this would happen is if it's going less on the first shot. And if it is, then we could decrease this for, let's just say, that's obviously always going to be the better way to do it. Increasing this could sometimes also work out, like here we could turn it to 5, but decreasing this is always going to be working. So for example, if we had 5, 4, 3, decreasing this would help for the first one, but it's not going to help there. Okay, yeah, so we can just decrease the first one. Yeah. Increasing the next one is never what we want to do. We always want to default to decreasing this one. That's why I like having this statement first. If that is less than that, then we could just make 8 the 5. And if it's not, then we could raise the 3 to be what the 8 was. Okay, let's see what we got here. Okay, good. I want to try some of my own. 5, 1, 5. That seems like a good test case. And then I also want to try 5, 8, 9, 3. So that should also return true. And then I also want to try 5, like 4. So then it's going to have to change too many numbers. Yeah. Okay, I think it's good. Well, I might get an error when num's a 0. Huh. There's one number in here. So we could say maybe if yeah, I'm trying to think. So yeah, we don't take care of if. Wait, yeah. Wait, why don't we take care of that? It would not. It would. Oh, we'd have. Okay. So we could say if. Okay, we have to also put nums.size is greater than or equal to 2, or is greater than 1, and this. So then it should work for that and also work for 2. Huh. Okay, well the size is not greater than 1, so then it should just return true. Okay, I is 0, but the size is 1, so this should never run. Then if num size is greater than 1, which it's not, so that's false, so it automatically should return true. Why am I not returning true? Get that in there. Do you guys see this? Where would I be returning false? So it shouldn't be going in there, so see out here. Whoops, not right now. Let me just do that. No, it didn't get there. It couldn't have gone in here. Could it? Wait, no, not that. How could it have gotten in there? The size of nums is... Whoa, 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 whoa. Okay, this is weird. How could it be going through here? There's only one thing. Nums.size is what? Okay, this is just weird. What is nums.size? Okay. Okay. So is 0 less than -1? This is so weird. Okay, I don't know what to say. This is messed up here. All I'm gonna say is that I'll just say if nums.size equals 1, return true. If it's 2, it should work. There you go. All right, guys. I don't know what was happening there with that. That was really weird. Something about maybe a negative number not converting well. That's probably it. Maybe I had to cast an int on it because size is technically an unsigned int. Ooh. Yeah, maybe that's why. Actually, let me test that out. What is cout nums.size -2? Let's see what they give us there. Oh wait, it's not even gonna run there. Yeah, okay, that's what I thought. So what you have to do, I guess, is do num here, or not num, int. Yeah, sometimes that happens with unsigned ints, because nums.size is technically an unsigned int, so it can't have a signed thing. So I guess it just starts at the beginning part again. Like after you subtract 1 from 0, it starts at int max. I think that was int max. Okay, right. That's what you have to do there. And then we could do it like this. So we have that, and then we have this part. I just think this looks more elegant here. So the size, if it's greater than 1, and that, then we could return true. Good, okay. Okay, submit final time, and let's see, hopefully it's still good. All right, I doubt that changed it that much. Sometimes leak code is finicky. All right, well, I hope you relaxed and enjoyed this episode. I'll see you guys next time.